We're going to illustrate a screening Pew matrix by evaluating ideas generated by students at Rice University for a Design with Disabilities project. The challenge presented was to develop an eating utensil, specifically a spoon, to help kids with arthrogryposis eat more independently. So individuals with arthrogryposis have limited range of motion in their arms and hands, as well as power in their grip. So these individuals are able to extend their arms, but they're not able to flex their arms. In other words, they struggle to bring their hand to their mouth, thus limiting their ability to feed themselves independently. The target market for this project are kids ages 5 through 12 who are in the public schools. Ideally, the spoon should be able to be carried in their backpack, allowing them to be independent during the school day. In this video, we're going to set up and complete a screening Pew matrix for the design of a spoon for kids with arthrogryposis. We identified 6 design criteria: time, transport, ease of use, lightweight, durability, and cost. So for feeding time, the design criteria is to reduce the time in half as compared to eating without a modified spoon. For successful transport, the design criteria is that 80% of the food that is gathered up by the spoon ends up in the individual's mouth. For ease of use, the design criteria is that 70% of pediatric patients with arthrogryposis can grip and use the device without assistance. For weight, the design criteria is less than or equal to 200 grams, which is about equivalent to 2 metal spoons. For durability, the design criteria is that it lasts greater than or equal to 1 year. And finally, for cost, the design criteria is that it is less than $20. Solution A attaches to the arm of the child. They use their other arm to pull a string which transfers the spoon from the plate to the mouth. Solution B is a telescoping spoon. You can use a trigger button to extend the spoon and a different trigger to retract the spoon, moving food from the plate to the mouth. Solution C is a device that attaches to the table that gives the child a lever arm to bend their elbow to move the food from the plate to the mouth. Solution D is a 4-bar linkage. When the device is extended horizontally, the spoon is close to the plate. When the edges are pushed in, the spoon extends and delivers the food to the mouth. Solution E is a long spoon with a right angle. The end of the spoon attaches to the glove, which the child can wear, facilitating eating. Solution F is the Winsford feeder, a commercial product on the market. It's a mechanized device that operates a little bit like a turntable. The plate spins around, the spoon collects the food, and then delivers it to the child's mouth. Solution G is a long spoon, like Solution E. But this one is made of materials that can be bent and molded to fit the particular preferences of the child. Solution H is like a Ferris wheel. Here, a number of spoons are attached around a center axis. They rotate, scooping food from the plate and delivering it to the child's mouth. Solution I is a series of half cups attached with magnets. Here, the child scoops the food from the plate and then transfers the cups up to the mouth to eat. In Solution J, the team proposed using a ball and socket joint. Here, the child can manipulate a lever that moves the spoon from the plate to the mouth.